Good morning, everyone. I am Dr. Rajesh Varma, and I'm the professor of practice out here in VNR, VJIT. And today we are going to discuss about generative AI, and briefly we'll be touching upon these topics that you see. Like we'll be touching on generative AI and the architectures which are there. We'll be also touching briefly about prompts, LLMs, and the use cases which are there. Okay, so just to let you know that we are in the era of generative AI, wherein we no longer do simple AI, but we do generative AI. And what's that all about? We'll come to know. Okay, so we have gone through the era of machine learning, then deep learning, and generative AI has now come forward. So we have traversed this particular path from the 1950s, I would say, a long path, and we have had a AI winter, and subsequently we are now on to generative AI. Okay. Now, what exactly is generative AI? That is what we need to know. Now, we have had generative AI, and then, as I told you, that we have gone from AI, machine learning, deep learning, and now we are on to generative AI. So, what we are really doing in this particular thing, in the generative AI, we are going to generate some of the images, text, and speech. That is what we are going to do. And the fact that we are going to generate is by introducing a little bit of noise. Okay, so what happens is that the real image, okay, and the image that comes out is going to have some noise in that. In this way, we can generate the images, or we can generate the text, or we can generate the speech, or videos, and so on. We go ahead with the generative AI. Now, how really does it work? Now, one of the architectures that we have is the GAN. Okay, the GAN architecture, it is the generative adversarial network architecture, and the other architecture which you have is VAE, that is the variational encoders. Now, let me talk to you about a GAN architecture. What really we do out here? As the name suggests, on one we are going to generate some of the new images, text, or speech, and we have a discriminator out here. So the discriminator is going to discriminate from the real image to the fake image. So that is what is the GAN architecture that we'll be using in case of generative AI. Now, let me take you through the VAE, that's the variational encode autoencoders architecture that we have. Okay, here what we do is we provide the input, and then first of all we do the encoding. The encoding, because like we all know that if it is a simple text, it has to be put to a vector notation, and that vector notation is done by the encoding network, and subsequently it has to be decoded. So we need a decoding network. So this is MNIST data which we are passing it through, and as you can see, encoding is done, and then subsequently decoding is done. These two architectures, GAN and the VAE architecture, are basically important for the generative AI. Now, there are different types of generative AI. Now, one of the types is text generation, wherein we generate different text. For example, if you take OpenAI, if you take GPT, ChatGPT, Llama, and all these are basically the architectures which help to generate text. Now, we have a second type, which is a presentation file generation. Now, if I give a particular presentation, it will generate me the presentation file. Some of the software, which is a beautiful AI, okay, the Canvas, the Power Present AI, these are some of the architectures which help to generate the presentation for me. Now, image, that is very, very important. And it helps to generate the new images. For instance, DALI 2, you must have all heard about DALI 2. It's very famous, and that is the architecture which helps to generate all the images. Okay, stable diffusion is also very famous out here, and that is what we do. That image editing, so we can definitely do the image editing of the images that are basically generated. Okay, now just have a look at this, in which we do the image generative fill. So we have done the filling of the image, and here also, as you can see out here, we have done the filling. So that can be all done via the use of generative AI. Now, the other one is the graphic design generation, in which we do the graphic designs and we basically go ahead and subsequently come up with the generative AI graphics design. Some of the examples in the are the design AI, the Canvas, Adobe, okay, and there are several examples of that. Now the videos are basically very, very important, and then you have to note that, for example, the neural frames are there, the model scope is there, okay, the text to video is there. These are some of the generative AI tools which are there in the market, which help to generate the images. Now, other human cloning avatars, and these are basically going to work for us like generative AI. They're going to clone and like humans. Some of the examples that are there are Aftarify, okay, Deepface Lab. Okay, so these are some of the human cloning avatars which are there. The video auto editing is also one of the type of generative AI applications. And then Magisto, the Adobe Premiere, these are some of the applications which are there. Now, coming to audio, we can also go ahead and generate the audio through the use of generative AI. And when we generate audio, we can basically clone some of the voice which is there by giving the original voice and then having the fake voice, and then basically we can do it. So the example of this particular software is voice cloning. We can do that using the generative AI. We can also generate the music. Okay, so in music LLM, okay, we are basically going to have out here, and the synthesizer, okay, text to song. So all of this can be done. Now, the question that is there in everybody's mind is generative AI a threat or opportunity for my business? And how exactly can I use generative AI? And how can I use my data securely with generative AI? These are the questions that everybody has in mind. That's fine. We'll answer it throughout the presentation. Okay, now let us see some of the topics which are there and that we have to clearly remember. Okay, the first terminology is the type of models that we have. Okay, and then we should also note that we are going to use LLMs, the large language models in this case. They are called, and we need to think about those. Okay, LLM evaluation, LLM agents, okay, or LLM security, all these aspects we need to think about it. Okay, now the fact I want to tell you once again are LLMs are made by specific companies. Okay, as for example, when we take OpenAI, they have made a LLM. Okay, Now, Amazon has made a LLM. For example, if you take Falcon, if you take Titans, if you take Anthropic, these are all the different LLMs, and this can be used out here in this generative AI to basically do the work. Okay. Now, having talked about all of this, we also need to understand what is basically prompt and what is basically a LLM. So, okay, here, before deep diving in, we need to know why today only we are able to talk about generative models, because these are data models which are there, and these are deep neural networks, and these perform some several tasks. So that is why we are able to go for generative AI models. Okay, today we have large data sets, and that is why we are having uh, since we are having, we can put them inside LLM and give somebody our LLM. Then the LLM will answer all the questions which are there for us. We are having huge amount of computational power, and also we are having the innovative deep learning models. That's why we go for generative AI. Now, some of the use cases that we want to talk about are basically the Q&A, question and answer, the use cases which are there, the virtual assistant which are there, the language style, and all this translation from one language to the other, and all these things we can do it via use of generative AI. Okay. Now, let us see the Gartner hype cycle which is there. Okay, and as you can see, this is the typical Gartner hype cycle, and on the top is figuring the large language models, LLMs per se, and then we have generative AI, which is basically going to use this large language models. So in the hype cycle also, we are basically having this generative AI on the top of the hype cycle. Okay. Now, what are the different tools which are there for the generative AI? The tools which are there are prompt engineering and language ops. Okay, the RAG. Okay, and the vector databases. So on and so forth. That Gartner has basically defined. We no longer go for the RDBMS or NoSQL. We go for the vectorized database that we go. For example, take for example the Neo4j is a vectorized database that we basically use out here. Now, what are the different applications we have? Okay, the different applications that we have are the generative AI enabled virtual assistant that we have, and the generative AI enabled applications. There are several of these particular applications which are particularly there, and that's how we basically build them. Now, let us talk about some of the architectures that we previously discussed. Okay, now some of the architectures that we discussed is that about GANs. One of the component, very first, is basically the generator, in which we create the new data example samples. Okay, and subsequently we have the discriminator. What the discriminator does is it evaluates the generated samples and then provides feedback to the generator. Okay, so it is going to generate the real one and the fake one. That discriminator is basically going to do that, and generator will basically generate the new data samples. These networks help us basically out here to do the generative AI. This is a typical Python program that I am showing you, and you can see out here that we have had a generator loss and then a discriminator loss. Okay, generator loss is basically, as you see out here, that in the below, that it implies the generator loss, and the discriminator loss it implies in the top, which is the blue. you can see that it decreases over a period of time. Okay, now we are also going to talk about the VAEs, the variational autoencoders out here. Now, what the components are basically the encoder and the decoder. In the encoder, we map the input data to a latent space, and in decoder, what we do is we deconstruct the input data from the latent space. So combining the both of them, we can basically have the VAEs, and that is what is basically in the generative AI. Okay, now see a small example that we have written in Python, and basically as you can see that we have the original data, we have the reconstructed data. So that is what we have done using the VAEs. Okay, now the other architecture that we have is that of a transformer. You must have heard GPTs and birds and all this. They all follow the transformer model, and it has become the very famous. There is a paper by Google, self-attention. Attention is all that you need, and the self-attention mechanism we generally follow when designing the transformer model. Okay, now here you can see that in this particular one we have plotted the heat map, and you can see out here that some of them are black, okay, in which we have basically a greater thing, and then subsequently we have done the plotting. Now, what does a transformer architecture look like? Let's refer to it from the bottom. Okay, we give a certain input, and the tokenizer tokenizes that into tokens. Okay, subsequently when it does the tokenizing, then we give it to the embeddings. Okay, and then subsequently it goes to the encoder. Yes, and then subsequently it goes to the decoder, and through the softmax it basically gives us the output. That is what we do in the case of a transformer architecture. Now, also we have the reinforcement learning with human feedback. So you can see out here that we are going to have some human feedback also out here given to the LLM, and subsequently we'll get the output out here. Okay, LLMs are what every company manufactures, and of course they sell it, and we'll use that particular LLM and then subsequently go ahead and get the answer. If it's a LLM for text, we get the text information. If it is a LLM which is basically for the image, then we get the image. On music, we get that. Okay, now we are going to do a generative AI project, and what's the life cycle of that? That's very important to know. Okay, first step is basically pre-training. Okay, we need to pre-train. Okay, and subsequently we need to give the right prompt. Okay, prompts are basically nothing but inputs that are given to the LLM so that the machine understands what really we want as the output, and subsequently the outputs are given. Okay, now we also need to fine tune. Okay, and then basically we need to have the reinforcement learning, and we need to give some human feedback. Okay, so that is what we need to do in case of generative AI. Okay, and this is what we do in case of a generative AI project. Let us briefly talk about prompts. Okay, so basically we have to understand prompts. Okay, now prompts are nothing but instructions that we give so that we get the right output. Here we have dealt in detail what actually is the definition of prompt and all these things, but Simply speaking, prompt is nothing but a input that is given to the LLM out here. Okay. See out here, the Python program. Here we have basically taken a particular prompt and we have basically subdivided the prompt into various components. Okay. Now, why we are learning about prompt engineering? That's very, very important. We are learning about prompt engineering because if we give the right input and we get we want the output from the LLM, then basically prompt engineering is very, very essential. Okay, now let us talk about the basic prompt. For instance, the basic prompt is having something like okay, suppose an instruction which is there. Okay, and then basically we just ask the particular input, we give it to the particular LLM and we get the output. Okay, now what are the components of a prompt? Okay, the components of a prompt are basically the instructions which are given to the prompt. Okay, then we give it some of the input data and then the output is what we get out of that. Okay, so we have to keep something in mind when we are prompting. Yeah, we should always keep in mind a few things. We should keep in mind that we should give the right input. Okay, and basically we should set our temperature and we should also set our top P. These are to be set properly. These are some of the parameters which we need to set when giving a particular prompt, okay, or when playing with the LLM. Okay, now there are some things that are there that we have different prompts for. Like we generally cover the different aspects like text summarization, the Q&A. All of these are basically, we basically give the right prompts and then we get the right outputs. Okay, let us take for example, I want to summarize a particular text. So in this case, I give it the right prompt and then that particular input text which is there, it basically does the summarization about that. Let us show you a Python program which is there and I have basically given the prompt so that we can get the summary of that. And as you could see out here that we have given the input and subsequently the summary is given to us. Also, we can give prompts for the getting the Q&A. Okay, and then basically if there is a particular thing that we question, that we have in mind, and then basically we want the answer, then we give the appropriate prompt and the prompt basically helps to give the right answer to that. Okay, here also we can give the text correctly and that will help us to classify the text which is there. Okay, so all of this can be done. The prompt can basically help us to generate the code also. Suppose we want to have the SQL code then and we give the right prompt, then basically the code generated will be there in the SQL form and subsequently we are done by giving the right prompt. Okay, also we can basically give the right reasoning for that and then basically the prompt will do the work for us, the output will be generated for us. Okay, now some of the techniques which are there for the prompt are basically the few shots. Okay, the chain of thought. Okay, self consistency, the knowledge generation. Okay, react. Like basically I have been talking about these particular techniques. Okay, I'm not going into much detail. Okay, I assume that you basically know about that. Okay, so basically let's talk about few shots. In few shots what we are doing, we are giving a few examples. to the particular machine, and then based on the examples that we give, the machine is going to generate the particular responses for us. Okay, in the chain of thought, as you can see, like I given a particular chain of thought, how really I have basically derived, and once that is given, the chain of thought prompting is done and the output is basically given to us. Okay, in zero shot, for example, there is, I do not give any examples, and it basically does the zero shot chain of thought. Okay, I can also do self consistency. Okay, as you can see out here in this particular examples, these are some of the ways in which we can give prompts. Okay, now I can also generate the knowledge prompting, which I can do. Typical example that we have out here is basically I give a particular question and then basically I get the answer for that. So these are some general knowledge prompting that I can do to the machine. Okay. Now this is a typical example that is there of general knowledge prompting example. Okay. Now when I deliver the right prompt, the prompt is also able to generate the language model for us. So program aided language model. So here what happens is that it will generate the program for me, that particular LLM will basically able to do that. I'm going to talk about a particular React framework, okay, where the LLMs are used to generate both reasoning traces and task specific in an interleave manner. Here, what is happening when I take React? Okay, so I'm doing some reasoning, and ACT stands for the action that I'm doing in a prompt. Okay, so these are some of the prompting techniques. Now, let me talk about briefly about the LLMs which are there. Okay. Now, what is LLM? Think of a LLM as a wealth of information which is there. Okay, and then basically what we are going to do is basically in the LLM that we are having the wealth of information. So that LLM is what we are going to use in our particular program to extract all the information. Please note that many of the LLMs are something which we buy and then basically we just use them. Okay. Now, this is briefly the phases of the natural language processing which you must be aware about. Okay. So then we'll go with this particular phase. Okay. Now, we want to talk about LLM. As you can see out here, that basically the size of the model is basically very, very important. When we say a large language model, it basically has billions of parameters in it. As you can see out here, in the case of GPT models, okay, GPT-2 had around a billion model, okay, and then subsequently we went up to 2, okay, and subsequently went to 3. So the number of parameters and it increased slowly by slowly. So these versions are basically there. Okay, let us talk about the large language models. Okay, they're slightly old, but as you can see out here, these are some of the models which are there. They are having a lot of information in them, and subsequently we are developing them and then going ahead. Okay, as you can see out here, this is basically the evolution of the LLM which is basically happening. Okay, so we have gone from the low parameters model to the high parameters model. That is what we have been doing and going ahead with the LLM creation. Okay. Please note that LLM creation by a single person is not possible. Okay. There are many people, a team, which is basically involved to create the particular LLM. For instance, OpenAI has a team which creates the LLMs. Okay, Stable Diffusion, DALI 2, they have a team. Okay, and they create this particular LLMs. Okay, now what are the best practices? We have to understand the model capabilities, and then we have to cleanse the model. Okay, and subsequently evaluate the performance and go ahead with regular monitoring and things, maintenance. We have to also interoperability has to be done. We have to have a robustness of the particular model, and we need to have responsible use and then continuously do that. Now, why are we using our LLMs? That is very, very important to understand. We are using LLMs so we do not underfit or overfit, and then basically we basically have the right fit and we can go ahead and do that, because you know that the LLMs can hallucinate. Okay, so that is why we have to have the right fit. We should not be doing underfitting or we should not be doing overfitting in any case. Okay, now this is about the LLM. So we need to have generalized LLM which can cater to all the cases in a general manner. Okay, and today LLMs are not hype. Okay, they're going to change the AI game. Okay, so as you can see out here that we have talked about some of the LLMs, okay, which are practically out there, and some of the companies, as you can see, that they have talked about some of their LLMs and given us a view. Okay, now how do LLMs work? We have a little bit of input, and then we tokenize that and we embed that, and subsequently we train it. Okay, then transformer model is generally used, and subsequently the output is basically given to us. Also, we may use the human feedback, but the encoding and the decoding, which basically happens in the transformer model, is basically helping in creation of the LLMs. These are some of the common LLMs, and we use in the industry quite a lot of these LLMs. We use the Chat GPT LLM, we use the Falcon LLM, the DALI 2 LLM, and briefly about these LLMs is what we have talked in this particular slides. Okay. Now, what are the LLMs which are used for NLP task? Okay. Now, the common LLM tasks are basically the content creation, summarization, Q&A. All these are tasks which are there by the LLMs. Okay. Now, if we talk about some of the use cases, like if we talk about the feedbacks, if we talk about the feedback analysis, if we talk about the virtual assistant, all these are something which the LLM can do out here. Now, these are some of the use cases of LLM. They can write stories for us, they can do all the technical writing, they can do article writing, and all these things that can basically do for us. Some other use cases are the customer support. Okay, and some of like automated, we can give a customer response to that, and social media or sentiment analysis. All this can be done by the help of a LLM. Okay, these are some of the other cases of LLMs. They can generate the code for us, they can detect the error, and they can convert the code, okay, between languages. So all this can be done by the LLM. Okay. So basically we have a advantage when we are using the LLM out here, and they come in different flavors. They come as open source model, they come as proprietary model also, and we can use any of them. Whichever suits our needs, we can basically use that. Okay. It is very important that we choose the right LLM, and then basically it depends on the quality, it depends on the cost. Let us see, these are some of the criteria that we need to keep in mind in order to decide what the LLM we have to purchase and we have to use. Okay, now what are the pros and cons which are there of using a LLM as a service? Okay, the pros that's there is the speed of development is very high. Okay, so that's one of the advantage that we have when using LLM as a service. The cons is basically the cost. Okay, today everybody is looking after this particular thing of cost and trying to reduce that. So LLMs, when we purchase from any of the companies, they are come at a good cost. Okay. So these are some of the pros and cons that we have taken. Now, one more thing we need to mention out here is the fine tuning of the models. When we basically fine tune a model, we have the model which is basically for a specific task only. Let me take you a simple example out here. When we are purchasing the medical data, for example, and we have a LLM for that, okay, health LLM, okay, then what we do is we basically take it for any of the disease which is specific to Africa, for example. So if I have to tune my LLM for a specific disease, then I take the generic health LLM and then basically I give the data of the country and the specific disease for that. I give all the parameters, and that's how I fine tune my model. So basically this is the cycle which shows that how I basically fine tune a particular model. Okay. So once I fine tune it, then basically I can use it specifically for that purpose. I can basically do that. And these are some of the open source quality which is rapidly advancing, but and fine tuning a cost which is there is rapidly decreasing. Okay. Now I also need to tell you that we are mixing LLM flavors in a workflow. Suppose, for example, we are having a particular LLM and then we are mixing it in a workflow. So that's what we are doing it. Okay. Now, here is how you basically do that. We are going to mix it into our initial solution, and then we definitely get a better solution when we do the mixing. Okay. Some of the challenges when doing the fine tuning. Okay. And in case of generative AI, what are the risks which are there? The risks which are there are the privacy, the security, the bias, okay, the missing information, the impact on the environment. These are basically some of the risks which are there when we are using the AI. Okay. So here we need to talk about data privacy. And data privacy, we have to ensure that data anonymization, encryption, and all these controls need to be in place when we are using this generative AI. Okay, so as I've told you earlier about generative AI, we need to maintain the data security, which is very, very important. Also, we got to audit this generative AI report. In this, we are basically showing you how to audit that. We have to have a model audit, whether the model is working properly, not work properly, all that we have to do. And then finally we have to do a governance audit, and we have to do the audit. So all this is what we need to do. Okay. Now, how will it impact the society? Okay. Where the pros is basically that it will be generally personalized to everybody's uh, instance, and that's the good part about it. But will it displace the job? Probably yes. Probably it will create different jobs. So that's what we need to wait and watch and go ahead. Okay. These are certain of the things which we are trying to say. Okay. What LLMs bring onto the table. Okay. And we definitely want to say there is a huge amount of workforce that need to be reskilled. Okay. And as you can see out here, 44% of the workers need to be reskilled because of the generative AI coming in, and that's what we need to do. Okay. Uh, we have briefly talked about LMs, and as you can see that they are basically going to change the game. Okay, this is about the history, and as you can see from 2017 we have had the LMs come up, and till today the LMs are basically being evolved, they are coming up, they are being refined, new versions are coming in. So we need to be all careful that these LMs are coming, and we need to use the latest LM as much as possible. Okay, we did discuss about pre-training, we discuss about fine tuning. So basically all the LMs are basically going to do that. Okay. Now when we say pre-train a large data set for data X, then we basically fine tune it on for data set for task Y. Like I was giving you that particular example from the medical domain, we need to pre-train our data set LLM on a particular data which is global data for the health, but we need to fine tune it for the disease in Africa. We can do that, and that is basically what we need to do. Okay, we also need to know about prompting that we need for the right output generation. Okay, and when we are doing the generative AI, okay, we are going to definitely use the LLMs, and that basically we need to talk about two parameters, and we need to ensure that we need to set the right temperature which is there. Okay, and then also we need to have the top P priority set to 0 to 1, which is basically nothing but the probability, and the temperature we need to set to 0 to 2, which we need to do in case. Okay. Now, these are basically the alarms that we basically need to use it. Okay. We have talked basically about the transformer architecture, and as you can see in this particular diagram out here, in the transformer architecture we do the encoding first. So given a particular sentence, we basically need to do the encoding, and subsequently when we do the decoding, so it basically given a particular input in a particular language, the output can be got in a different language. That is what we do in the case of transformer architecture. Okay. Now we have other architectures like the BERT and all these things which we have. Okay. And what are the risk we need to understand very clearly when we are doing generative AI. The hallucination that we spoke about is one of the biggest risks that LLMs can make. And when we say hallucinate, it gives us the output which is wrong, although it appears to be correct. So we need to ensure that we basically are careful about such a risk that the LLMs can basically make. Okay. Now, what are the best practices that we have for the LLM? We need to understand the model. Okay. We need to process the data, and then subsequently we need to evaluate. And regular monitoring we need to do. We need to have the interpretability and subsequently robustness, responsibility, continuous learning. So that is what we need to do in the case of LLM. Okay. What is the future of LLMs in case of generative AI? Like I would say that we need to make our LLM continuous, scale it up, and it needs to learn continuously. Okay, so that's what we need to do in case of LLMs. Okay, we also need to have our LLM as a responsible LLM, so it can do the responsible AI thing very well. Okay, and this is the current state which is there of the LLMs. As you can see, the different LLMs are out here and they keep on growing. Okay, and I told you that when we evaluate a particular LLM, we evaluate a particular LLMs by the millions of parameters that it has. Okay, small program out here in which we have given a prompt, and this is we have generated a prompt for generating a continuation. So this is what we have done. Now also, as you can see out here, we have written a small program out here in Python. Okay, so we have done that. So the conclusion is the LLMs are becoming ubiquitous. They are all over the place. Okay, the LLMs are being rolled out commercially. Okay, and then we have to get used to it. Okay, and there should be government regulations which are likely to follow 2 or 3 years later. So this is what is basically about the LLM. Let me talk about some of the use cases of generative AI. Some of the use cases of generative AI are basically the content generation, the Q&A, the virtual assistant. Okay, these are some of the use cases of generative AI that we can have going ahead. And when we generate the image, this is also one of the use case of generative AI. We can do that. Okay, and we can do a simple image or a 3D image. We can do that. These are some of the use cases that you see out here when we are doing the generative AI and how it is generated that particular image. Okay. Okay. Some of the things that we have we can do by the generative design are basically the discover drugs. Okay, and design unique systems. We can definitely do it using the case of generative AI. Okay, these are some of the references. These are some of the academics paper. I strongly encourage you to go to these particular questions and basically have a look at this. Okay, these are some of the books which are there. Okay, and basically start with okay, what is generative AI, and then subsequently we go ahead, and then lot of books are there that we can do, and orally books are there we can do, we can learn about the LLMs and when we are doing generative. Thank you very much for patiently listening to me, and happy learning to all of you. Bye bye.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.